Hi, everyone. This is the DeSci Labs October 10th community call. Today, we're going to be talking about plurality, pluralism, whichever you'd prefer to call it, badges, markers of quality, and the concept of soul-bound tokens with respect to science. It's going to be a great conversation. I'm excited to hear what gets said. That being said, just a couple quick updates beforehand. As always, we have community calls on Monday and onboarding calls on Wednesday. We are changing our Tuesday call, which is normally around alpha testers, to now be around node stewards and folks who get to interact with the product to help showcase open science itself. So for anyone who's interested in that, John has posted in the general channel about the Node Stewards program that is just now starting. So there is a Notion page about it called 100 Cute Nodes, and I'm happy to add that to the YouTube video as it gets posted. For anyone who is immediately interested in helping to highlight the power of open science and open state repositories and what that can look like in the future, please feel free to join the calls. They are going to be on Wednesday and Sunday as outlined in the respective posts. So we hope to see you there. We're also going to be having, a couple things from the DeSci Foundation, which maybe Carla can quickly fill us in on around the future of science seminars and some of the podcast talks and series that we have. Carla, are you in a place where you can speak?
Yeah, for sure. I have a background noise, but I can speak on it. So, we did put out a episode on the future of science podcast, our first episode. It's a follow up to the conversation from the very first seminar that we had in prior with Gustav Nilsson on the quality control of research objects. So that's out on Spotify. It's on Apple Podcasts and Google. Check those out, share, review, leave a like, give feedback, all that stuff.
All right, sounds good. Thanks, Carla. And then just a couple other quick house cleaning updates. We have a couple different events that we're at the moment. So I think Philip is currently at the Foresight Institute's event in San Francisco. The team is going to be at Funding the Commons in Lisbon in the near future and IPFS camp as well, where I believe Carla will be giving talks at both events. There's a Fair Digital Objects conference in Leiden that we'll be going to. And then I'm trying to think if there's anything else. There's so many conferences, it feels like I'm missing something here, but that's at least enough for the moment. And with that being said, I think that's pretty much it for the updates that we wanted to give today. John, I see where you just jumped on. I already briefly covered node stewards, but if there's anything you want to add outside of just the general purpose and the meetings, please feel free to jump in.
Nope, nothing.
All righty, sounds good. Well, with that, let's go ahead and get on to the topic of today's call, which is plurality, badges, SBTs, and markers of quality in science.
Yeah, great. It's a really interesting topic, and it has everything to do about creating alternative metrics for science to reward and track what is quality scientific work. Essentially, going back a little bit into the history of why this has happened, I think a lot of this effort can be traced back to the replication crisis that was raging through psychology a couple of years ago. I mean, still is today, arguably. And there was a group that formed that was called the Open Science Foundation, and which later became the Open Science Framework by a really great guy named Brian Nosek, who cared a lot about open science. And around this time, there was this idea of creating these alternative markers of quality, and to essentially showcase best practices in science. So some of these best practices, of course, are very field specific and field dependent. So the type of best practice in a wet lab are not going to be the same as the type of best practice in cognitive science, although there are some definite commonality. So it started with the Open Science Foundation. And essentially what happened is that they had this idea of creating badges. These badges would essentially be marking attributes of published research. For example, is the code and the data open? Has the work been pre-registered, meaning that there has been a plan that was submitted beforehand, before the data collection, before the data analysis, that was specifying the types of outcome variables, the type of statistical test that would be conducted, and all of these things that are actually essential to reduce what's known as the garden of forking path or researcher degrees of freedom, which tend to be to really have a huge impact on reproducibility and actually on replicability of published work. So essentially the idea of pre-registered report is that if you do pre-specify in advance your analysis plan, you pre-specify the type of dependent variables, the type of outcome variables, your hypothesis, how you're going to go about collecting the data, that is a very, very, very strong indicator of research quality and replicability. And the reason for that is that scientists, after data collection, they have all sorts of options that are open to them to analyze data. And very, very often, it's actually quite easy to essentially justify pretty much a large variety of practices which essentially have bad consequence when it comes to statistical inference. So statistical inference and hypothesis testing has a lot of very stringent essentially preconditions to it to be done right. And when you start having multiple choices on how you might analyze an outcome variable, which outcome variable you might track, these types of things, that tends to dramatically inflate your risk of type 1 error, right? Which is essentially finding an effect that doesn't exist. So long story short, these badges have been widely successful and have been shown not only that there's a lot of demand from authors, but that they actually encourage and increase the reuse of materials. And so the Open Science Framework, the Open Science Center, has been very successful after spending years and years and years to try and get journals to adopt some of these badges. They finally had scored an absolutely major success, which was to essentially convert Psychological Science, which is one of the top journals in psychology, to adopt these badges. And one could argue Psychological Science was in an especially a difficult position a couple of years ago, because being a high impact journal in psychology, it tended to publish a lot of non-intuitive findings, right, that were based on small sample sizes, that also had a lot of risk around the garden of forking paths and these problems. And so they really needed a solution to increase trust in the type of studies that they were publishing. And essentially they teamed up with the Open Science Foundation, and they created essentially every article that's published on psychological science has these badges, and they have the material that is linked up to the Open Science Foundation. So that was the the origin of these badges. And then a couple of years later, I believe that the ACM, so was inspired, so the ACM is the Association for Computing Machinery, and they were likewise inspired by the success and the efforts that were done by the OSF, Open Science Foundation, and they started releasing badges of their own. And they were badges that were essentially tailored for computer science, that were essentially checking if abstracts submitted for conferences. Remember, computer science is a discipline that works on conferences, very competitive conferences. They were essentially checking if the abstracts submitted in the conferences were accompanied by code, were accompanied by material, by artifacts that essentially had certain properties, like they were well documented, like the artifacts could be reproduced, the artifacts could be replicated. So they essentially joined that effort, and they issued badges of their own. The most notable difference between the ones of OSF and the ones of the ACM is that the badges of the OSF are essentially badges that the authors specify essentially what they believe is deserved given the material that they will make available. Whereas at the ACM, it's in the conference verification process, application process, that there's essentially a committee that verifies if these badges that the authors are claiming they deserve are truly deserved, right? So these are two different approaches. The former approach has the advantage that it's much more, it's much easier to essentially do, and the user experience is much better, but then there's problems around trusting the deservingness of these alternative markers of quality. One of the things is that, so there was a study recently showing that some of the badges that were on the page of psychological science were actually not really deserved. And I think I can link to that study later on, but there's essentially community efforts around these disciplines to think of better ways to verify and to ascertain whether or not these badges are deserved, and to come up with rather stricter definitions and criteria and verification procedures around that. So that's a little bit the story around these badges. And you could ask, well, why does it matter? The reason they're actually found onto something really fundamental, right? Because the essential currency of science is citations, right? It's a number of papers weighted by the number of citations, right? And that's a very limiting currency. First of all, because citations are a very noisy indicator, right? A paper can be cited because it's bad, and the author wants to make a point that it's bad. A paper could be cited out of respect, out of deference, to basically signal that you're part of a club. Typically, this happens with these old papers that gather. At some point, there is a breakout velocity for citations, and a paper starts just to accrue infinite number of citations. Well, not infinite, but very large numbers of citations, because they become part of the corpus and the social club. So there's these obvious restrictions around this question of currency in science and citations. And of course, there's also the citation of a paper that is actually so critical and so key to your work that without that work, your work could have never come to be. And there's also no way to really decide on what's a super citation. So you're left with very coarse metrics, would essentially end up being summarized by what's called the H-index, right? So the H-index, if you look up on Google, you look up the name of an academic, you'll find that he has a certain H-index score, and that H-index score is essentially a metric that's based on the total number of papers published and the citations accompanying that. And of course, the higher the H-index, the more the higher the reputation of its author, and these type of things. So badges are important because they essentially provide alternative metrics that allow funders and other people that are other stakeholders in the system of science to actually get a better measure of what they've been essentially sponsoring. That they can now check if these works follow best practices in open science, if materials that are actually very valuable for other scientists have been posted along the original material. So that's a very important signal, especially in this era where funders around the world want to get more bang for their bucks when it comes to data reuse, to artifact reuse, code reuse. All of these things are now becoming more and more important for funders worldwide to essentially track, so that they can improve the pace of knowledge production, right? So where does that bring us? Essentially, there is so what do we know from these experiments? So we do know that badges increase the propensity of authors to share materials, and we do know that these badges like pre-registered analysis plan increase trust in results, right? They definitely do increase trust in results for me big time, and many other scientists out there, because pre-registered analysis plan especially are very constraining, and they do provide you with an excellent proxy for how much you can trust a study based on statistical inference. Badges such as artifacts available, they're reproduced, they're attached to the work, are also likewise extremely valuable, because all of a sudden, if you're a scientist, it's not, you're not going to be ending up in the rabbit hole where it's like materials available upon request, and you end up having getting ghosted on the other side of the email chain. In that case, you can directly access the artifacts, download them, and start testing them, and essentially building your own research on that, right? So they're extremely valuable. And one could argue that the concept, in general, that concept is something that, because it's been so successful, so popular with authors, that it's something that really deserves to be extended. Right, so you could imagine funder-specific badges. You could imagine badges by professional organizations beyond OSF and ACM. You could imagine a whole world of alternative markers of quality and ways that these alternative markers of qualities are considered by funders and other professional organizations for benefits. One of the things we're quite excited about is, like, imagine you're a funder, let's say the Wellcome Trust or another type of science funder. You might be able to say, hey, this badges actually indicates that the scientist or the researcher that I funded, they completely comply with my funded mandate. They made their data, their code available. They really created this open science exemplar piece of research, and that matters a lot to me when I make my funding decisions. And funders also have a willingness to have these badges verified because they want to rely on high quality information when making these grant decisions, right? So they have a very strong interest in having more alternative markers of scientific quality, especially when it comes to data reuse. So you could imagine badges tracking things like reuse of digital artifacts in a way that's much more systematic and well done than what we currently have. You could have badges that track, characteristics of reproducibility, replicability, badges that track pre-registered analysis plan when it's convenient, or also perhaps even in the wet lab, you could have a badge that says, well, there's video material that shows how to actually conduct a procedure, right? Because that's the joke in the wet lab. It's like you read the methods and it says, well, you just take the region, you add a bit of paste, you put a bit of magic powder on it, and all of a sudden you have these transformations that happen. And very often, they're persuasively written, but if you are into a wet lab, you know that even though you've read the method, you have no clue how to actually reproduce this because there's so much implicit know-how in these types of methodology, right? So having badges that says, well, the author's methodology is particularly transparent, it's well described, it has, video examples, it has all sorts of material to really, really foster other groups and help them reproduce that work, right? So that would be the type of badge that could be very, very valuable, for example, for work performed in longevity. So essentially, there's an extremely rich, fertile soil to experiment with these alternative markers of quality. One of our hopes is that we will be able to create systems and workflows to return value of curation to scientific communities by having them not only conduct the peer review process, but also having the ability to select and verify markers, these alternative plural markers of quality, in the ways that it provides direct value and utility to funders of science, but not only also to research organizations, to employers, etc., right? So there's a very fertile ground here, especially given that one of the biggest challenges in badges is the problem of verifying these badges, right? That is an unsolved problem. The ACM SIGIT conference does it. It's very cumbersome. There's even blogs of computer scientists complaining that they need to verify these badges on top of doing the peer review process, and that it's very hard to get these softwares running out of the box. And so there's essentially everyone likes the idea of these badges, but nobody wants to pay for verifying them, and nobody wants to, really do that work on a pro bono basis. So there's essentially tension here. So the people that do have an interest in that are funders and research organizations, that they have a big incentive to get more bang for their bucks out of the research that they fund. And so that's what we're hoping to achieve, essentially create systems where you can interface these research objects with a system that allows authors to select badges from the communities that matter for them, right? So if let's say you're someone doing cognitive science, you might say, well, the badges that are appropriate for my discipline are the ones from the Open Science Foundation. If you're, computer scientist, will be, well, the badges that are appropriate and meaningful for me are the ones from the ACM. Let's say if you're, doing wet lab, you might have another type of organization. You might have funder-specific badges. You might even have the ability to, let's say, if you have 3 badges of one of these institutes, well, that means you automatically get the 4th badge badge, which is, a badge that says complies with the funding mandate of the Wellcome Trust within the domain of cognitive science on psychiatric research, for example, right? So you can imagine also interesting relationships around these badges that could emerge. Now, the term badge is a little bit silly when you think about it. It feels a little bit like, oh, this is like a Boy Scout mark, right? And it's you're dealing with something that's very, very serious, which is the production of new knowledge, right? So that's why we tend to call these attributes, right? Attributes of research, or you could even think about them as attestations of published research or attestations around research objects that tend to mark, that allow you to track a richer landscape of attributes. So we're kind of working around this. We're also hoping that scientists at the DeSci foundations and other people we're working with might be able to come up with taxonomies and new landscapes of additional markers of quality to essentially fill in the holes around some of them and fill in some of the suboptimal part about some of these badges. So for instance, the Acm badge that says results replicated, it assumes you need to have completely different artifacts, right? So you need not only new data, which is a given for any replication test, but you also need something like a completely new artifact, right? So that's like you need to rewrite the code completely from scratch, and that of course is a really, really big ask, and in some cases it makes absolutely no sense, right? Like, let's imagine you're relying on a third-party toolbox. I mean, you need to rewrite the toolbox to claim you have a new artifact. So there's a couple of rough edges in the way some of these badges are defined. OSF itself they've shied away from defining a badge that says results replicated or results not replicated, because they're a little bit afraid of, like, first of all, the adjudication process, right? I mean, deciding whether a given study replicates or not is something that's gets quite emotional and quite difficult in some cases. Although there's now much better methodologies around effect size comparisons and these types of things, but it's still a kind of like a risky thing in those specific disciplines. It's much less risky in other disciplines, right? Not all of them, but so essentially the point is, there's a lot of heterogeneity between fields of science. There's a lot of different cultures, the markers of quality for one specific fields are not necessarily the same across fields. So this is something where we need to be sensitive about that. At the same time, there's a huge opportunity to be extending the scope of badging to many other types of attributes. You could even say, well, things like communicating your work to the public, creating video explainers, all of these things have value and are, could be deserving of certain types of badges. Having fully reproducible research in interface, with Jupyter notebooks that allow you to completely reproduce the results. Well, what is that? That is like a new type of badge. It's not really explained by the badge that says your code and your data is open, or the badge that says your results are reproduced. It should be its own type of badge. It says, well, now you have the ability to completely reproduce this study inside out in your browser, right? Because you created a reproducible container linked to it. So there's a tremendous opportunity to build on that system that is popular with authors, popular with funders, that essentially brings tremendous value when it comes to creating trust in science, has roughness around the edges when it comes to verifying these badges and who verifies them, who creates the attestations that they are indeed deserved, right? And what are types of workflow to reduce the cognitive loads on people that verify these badges, and what are the type of reward systems associated with that? So that is a big question. And the last part, of course, is like, well, if we take that system, to its extreme, like what is the landscape and taxonomy of badges that we could create to really allow for rich plural metrics to emerge and to be attached to these research objects as attestation of certain of their attributes, right? I think it's very important to remember that scientific outputs are very dense. They're very take a long time to read. They require a lot of domain expertise to be able to form an informed judgment. And there's always that need to distill all of this, right, to a single number at the end of the day for funders especially, right? But the problem with the single number is you lose so much of the subtlety, so much of the importance it's just too coarse, and having citation weighted number of PDFs is definitely not something that's sustainable in the long term, and not something that's conducive to making better funding decisions and to fostering the creation of new reproducible knowledge. Whereas if you now have not only these metrics, but you have plural metrics that says, well, these researchers I'm funding, they tend to produce completely open access work. These works tend to have open data. The open data policies tend to be liberal. The licensing agreements, all of those are done, are comply with the ones I'm suggesting in my funding mandate. So all of that brings terrific value. So that's what I wanted to say on badges. I'm going to post a couple of links in the chat right now. So let's see, where's the chat? Yeah, so this is the ACM badges, so you can kind of have a look here. The open science badges, as well as some really high value links there. I'm going to give you an example of what it looks like on Psychological Science, which is one of the top journals in psychology, which had a really crisis of trust. I mean, I think that crisis is ongoing, and one of the ways they're addressing it is with these badges. Also post a link around the ACM SIGIR conference and how they see verification of these badges. So they do have guidelines on how to do that. Yeah, so, look at these resources. I think this is also a topic that ties particularly well with our inaugural seminar that we had at the DeSci Foundation concerning verification of research objects by using essentially having a holistic and detailed approach on the attributes of that research object. And I think Gustav, he also spoke of things like, well, it's one thing, to have a pre-registered report or pre-registered analysis plan, but it's another one to actually verify, right, that these pre-registered analysis plan have been followed in the final report, right? And we need methods, we need systems, we need workflows in order to be able to enable all of this. And it's vital that we do it. And it's also it's such a large space, right? This question of scientific validation, and it's something that is definitely worth spending a lot of time around optimizing, theorizing, and also practicing and seeing how we can create better systems that return value to scientists around it. So I've had a long monologue here. I'm very happy to take some questions and to essentially exchange with all of you.
I definitely have a couple questions. I would love to open up the floor to anyone else who's here first.
Yeah, maybe just a comment from my side. So Chris was talking about the pre-registered analysis plans at the beginning. And so my team has been using these pre-registered analysis plans on OSF basically since they were launched maybe 10 years ago or something like that. And it's a really, really powerful tool. The main thing that it does is that it basically forces researchers to think very carefully about what hypothesis they're ultimately going to test and how they're going to do that, and to create a track record about how they got to that decision, what their original plan was, but then also give them an opportunity to actually update the plan along the way if that is necessary. So these analysis plans, they basically serve two purposes in my mind. One is that they force authors to think much more carefully about what they're going to do before they're actually starting to collect data and to play around with it, which limits the degrees of freedom and ultimately often leads to much better study designs. But then second, it also just creates a track record for referees and for readers to basically see how the project has evolved over time and at what point, if at all, authors decided to deviate from the original plan, because that is often necessary. But the really crucial thing here is that you create transparency about the reasons for these decisions and then how you came about them. I find this entire system incredibly powerful, but I also know that a lot of researchers just find it burdensome because it basically means additional documents that they need to file, additional steps that they need to take. And very often there's also a bit of a concern that your ideas may actually be stolen by others, that you may get scooped for a particular good idea. And for that, OSF has actually implemented something that is really, really cool, which is you can pre-register your analysis plan and basically get a timestamp that says exactly when you have registered it and logged it in. But you're not forced yet at that point to make the analysis plan publicly available. You still have control over who you actually give access to this analysis plan. And what my team is typically doing is that we start with these analysis plans really very early on at the beginning of the project. We keep updating them, but we keep them in the private and only at the point when we actually have a paper and referees and readers need to see how we came to that paper. At that point, we make the analysis plan open. So I just wanted to add that as a little bit of an additional layer of information to that.
So one of the biggest questions that pops into my mind from all of this is how a scientist would deal with kind of, I guess, unknown unknowns. So if you have this strict, detailed, pre-registered analysis plan, to a certain extent, you have to make an assumption that I won't say everything at the beginning of a project, but a lot more than what you probably do. How do you deal with ambiguity in that context, in strict of a process?
Yeah, and that is exactly the point. So you're totally right. It's dealing with the unknowns that makes this difficult and challenging. So the main question that we're always asking ourselves at the beginning of a project is whether we start a project with a particular goal to test certain statistical hypotheses. And then, if that's the case, if there is a clear case to be made that there is a clear path forward, then it's only a matter of deciding what data you're going to use and what methods you're going to use and so on and so forth. But you can also say that your goal is to conduct an exploratory study, right? So where you're not tying your hands to testing only one particular hypothesis, but where you basically say, here's the topic that we're going to explore, and here is the sort of the approach how we're going to explore it. It still creates transparency, but it loses a bit of its power at that point. But I do believe that there is a lot of value in conducting exploratory studies, and very often this is where the most important results come about. But the really important point is if you did an exploratory study, you should not be in a position that you can actually claim later on that you were testing only this one particular hypothesis from the beginning. It's really about creating transparency along the way.
Yeah, and there's also the case that it does suit itself better to certain field of science than others. So there's a lot of little cultural differences here, but you could definitely say that pre-registered analysis plan should have way more uptake in the medical science in the sciences than what they have today. So there are lots of gaps. It's interesting because we think of psychology as, let's say, the not real science, the guys that have been, having the worst replication crisis and all of that. But actually, there's a lot of meta scientists that come out of psychology, and they've really tried very, very hard to improve a lot of the standards in their discipline, whereas that has not really been the case in a lot of medicine. So you could say, well, there's tremendous room for uptake for these pre-registered plans in these other disciplines, and it would be a really, really wonderful thing to create systems that create incentives around that so that we can trust the science we read more, compared to if we didn't have these badges and these alternative markers of quality.
And Flow Science, I saw where you came off mute just a second ago. Did you have a question?
Yeah, I just hopped back on because I'm on my morning walk and there's a truck driving past. But the whole idea of this pre-registration of analysis plans, it's interesting. I think it comes back to me to data collection and the distinction between are you just doing an analysis, for example? For example, for my graduate research, I did an RNA sequencing study where I was looking at a time series of regeneration and taking samples and looking at gene expression. didn't really have a particular hypothesis about, say, like what particular pathways were going to be, maybe, yeah, there was a couple based upon, comparison to other species and things like that. But I was working and doing this essentially exploratory study in a species that hadn't had this done before, right? So that was, we had some expectations, and sure, there was some baseline hypotheses. But what if, for example, somebody else comes along and they have a hypothesis and they say, oh, this data set is perfect for that. I'm going to use this data set, but they didn't collect it, right? And so they may have a specific hypothesis, but the data set wasn't specifically collected for testing that. So if it really comes down to it, like, to me, the distinction between whether something is more creditable or not is how specific was the data for the analysis, like collected for that, was it specifically collected to answer that question or to explore, that to test that hypothesis, or was there, which is fine. I think there's just a different level there in terms of the power of the study.
I mean, yeah, that's a super interesting thing. You could also argue that imagine you have a data set with 10 dependent variables, and you have a hypothesis. There's one outcome variable you're interested in. You isolate it, and you say, this is my outcome variable, right? And you have your pre-registered hypothesis that says, well, this is the one I'm interested in. Let's say, it's like the cell proliferation or what have you. And you have that outcome variable. It's very, very well defined, and you have your pre-registered report. You do your analysis, and let's say you find some sort of you fit a model. It gives you some sorts of results that appear to not have been caused by random fluctuations of the sampling methods, but there seems to be some structure or some information there, and then you can conclude, right? That's an inferential test. That's essentially inferential research. Hypothesis testing, and it conforms and it fits it. It doesn't. It's not violating the axioms of statistical testing. Whereas the other person who essentially has no pre-registered plan, he has 10 different outcome variables, and he tests all of them, and he reports the one with the largest effect size and says, well, I've planned this all along, right? It's only logical that it is this way. A lot of that is easy to attribute to malice, but there's also a lot of post-hoc rationalization that happens at people, right? So p-hacking in a way is kind of a strong term because it's like conveying the idea that people are hacking their results, right? They're actively misleading their readers. Well, very often what happens is that they just don't have that good of statistical training, or they come up with good rationalization or post-hoc. It's like, oh yeah, of course we should exclude this cell line because I'm pretty sure it was contaminated. The assistant left a note into it, right? And that's how you have these types of biases that creep in. But the more interesting point is imagine having 10 different groups, right, that all come up with a hypothesis on different outcome variables of this 10 set of outcome variables. What happens then, essentially, right? So they're using the same data set. They all have a pre-registered report on a different outcome variable. How should you treat that? How should that essentially affect your Bayesian beliefs on the probability of these results replicating, right? Given that the data set is the same, and they all independently came up with a pre-registered plan, and all independently did the things according to best practices when it comes to statistical testing. It's a good question. I wouldn't know.
Maybe I can add to that. So I think in general there is a difference between empirical studies that are being conducted on secondary data that have been already collected and being made available, and then there is statistical tests on data that you collected yourself. And it really depends on the study question which of these two approaches is the better. In both of these cases, there is a case to be made that a pre-analysis plan, a pre-registered analysis plan will probably help to improve the quality of the work that you do. So if you're studying secondary data, then the main issue is exactly what Chris just mentioned, is that very often you have very large data sets with hundreds or thousands or maybe even in millions of data sets, like in the case of genetic data, for example, where you have an almost infinite number of hypotheses or statistical models that you could test, and where binding your hands creates credibility and actually forces you to think very carefully about what exactly you're going to do. if you're collecting your own data, again, the issue there is creating transparency about why you decided to do it, what exactly the experimental procedure or the method is, whether you thought about effect sizes and statistical power in a realistic way, and then calibrated the sample size accordingly, and just create transparency about the entire process. And then also, in any case, it gives you the possibility to update the analysis plan later, to add an annex when you come to a point where you realize that your original ideas were either not working or you needed to extend it to test something that is potentially really interesting. But I think these pre-registered analysis plans, they're useful in both cases.
Can I perhaps add something about those badges that the verification of badges? So I have two related comments or questions here. Is that first of all, how does this tracks of record integrate with the data model that you are developing here at DeSci Labs? And why I'm asking you this is because it might actually solve this problem of verification, because verification might be just a function, that a predicate that you evaluate on your data. So in that sense, it will be just automatic.
Yeah, so I think so verification of attributes. I doubt there's a lot we can automatize there. Though things like code has been posted, artifacts available, these types of things can be done automatically. But then again, there's of course the risk of having let's quote unquote spam artifacts, right? So there's still a necessity to verify them. In general, the big questions is like, what are the efficient workflows to verify these attributes, right? What are the efficient workflows to verify that, let's say, a pre-registered analysis plan has been followed, that the data is available and it's a complete data set, and it's a quality data set that's well labeled, has appropriate metadata, essentially has all the characteristics of a good scientific artifact. So these are just, I don't think there's any cookie cutter simple automation systems, or even going down the path of AI. I think that's also not something realistic, especially in the short to medium term. So yes, all of those will be these are labor intensive things, and I also believe that by virtue of them being labor intensive things, there's also ways in which we can make them less labor intensive, right? Like if you have a unified interface where you can actually access, navigate between all of the different artifacts, where you can test them, when you can run the code, when you can look at the properties of the data, or you could even like run summary statistics on that data, and just essentially hello world that data and make sure it's there. So all of these things, there's essentially a lot of potentiality when it comes to improving the workflows to verify these attributes, and I think that's a really exciting area, because there's absolute concrete ways to add tremendous value to these existing organizations and scientific communities out there.
So, Chris, another part that I don't know if we've touched on yet, which is interesting to me, I know it's something that John has brought up quite a bit, is the concept of plurality in these badging systems. I'm wondering if maybe that's one you can touch on just a little bit.
Yeah, sure. I think so. I think so. There's a movement around plurality, and it's a movement that has very, very broad ambitions. I can actually link this. It's from the Radical Exchange Foundation. It's essentially a movement around the production of plural network goods, and how to create how to create the conditions, the tools, the systems in which you can have better public goods, better network goods emerging from society as a function of interaction of its members. I think in general, in the case of science, you want plurality, plural modes of publication, right? You should be able to publish different things in different ways, and we should have a plural ability, the ability to cite things and to create chains of provenance between intellectual artifacts that are published out there in a way that allows us to capture a much richer scope of media and mediums as valid artifacts of knowledge. So there's the plural publication. There's also plural markers of research quality, right? You can imagine systems, and what we've described, right, with the badges is a way to create plural markers of quality. Ideally, you want to have bottom-up groups and top-down groups that both work to create alternative markers of quality that they themselves accrue certain reputations and certain standards that are then seen as being valuable and trustworthy indicators of different aspects of scientific quality. You can even imagine indicators of quality that are you might have plural curation, right? Plural curation is another thing, having different types of editors or scientific societies, curating what they consider to be, the most ambitious work or the most, essentially the most valuable work that's been published in a certain quarter, certain period of time. They might have different views on that, right? And you want them, these different societies, to be able to cultivate reputation around these views as, reliable oracles of what is something worth paying attention to, because at the end of the day, it's all about, amplifying and managing the limited attention span. There's just too much science and too much bad science produced out there. You can't pay attention to everything. You need filtering mechanisms. You need curation mechanisms. The real thing is now, scientific publishing is not plural at all. You essentially have 4 big publishing companies that own more than 50% of the market. All the other ones, and they have staggering profit margins, and the other smaller publishers are struggling tremendously, right? So there's also this problem of you want to have plural models of sustainability for these communities, right? So, and then it's the idea that the more the more you can lower the barrier to entries, the more you can create efficient systems for societies and groups and individuals to coordinate around and to issue, markers of reputation, affiliation, or attestations, right, which are what these authors call SBTs, right, soul-bound tokens. The better tools you can create to allow for the emergence of more plurality, the better you might be able to coordinate on the creation of network goods and public goods, and science being a public good, right, a knowledge public good. It's one of those topics that really, really fits very, very well within that framework of plurality.
It'll be interesting to see the way that top-down and bottom-up approaches work for a lot of these different badging systems. One of the things that I've kind of noticed as we've been talking throughout this call is, I guess there are a couple different ways that badges can be issued. And it seems like a lot of them will get issued at the very beginning of a piece of science, and a lot of them will get issued post facto in terms of review. And it's, I guess, as you're thinking about a pre-registered analysis plan, this should all be done well before the actual paper. But as you're looking at, let's say, code and data available, or a couple of the others that you mentioned, it's definitely post facto. Do you see any difference between the things that should be issued before a paper versus after in terms of top-down versus bottom-up approaches?
Yeah, I think there's many different ways to go about that. In general, I'd like to think that every scientific paper, every knowledge artifact should have an inventory, right? An inventory that holds attestations. These attestations related to the properties of that knowledge artifact. And then you can have, there are different types of properties, and there's of course different timescales in the life of these artifacts where different properties can be earned. One of the things is, you could imagine, even the fact of being peer-reviewed and published in a journal. Well, what is that? Well, that's an attribute, right? What does that attribute say? Well, it says a number of things that are not made explicit in the current system. It says, well, first of all, it says it's unlikely that the work has been plagiarized because we checked it, right? So this is like something very basic. It says much more. It says, well, it's also very likely that this work is thematically appropriate for our collection, right? Collection. Let's say, we call volumes and papers and journals. You could think of these as collections. Thematically appropriate for a collection. So it's not off topic. Well, it says more things. It says, well, it's also been peer reviewed, right? So we've sent it out to peer reviewers, either a closed or open peer review. Maybe the peer reviews are attached, maybe not. But that at least, there's 1 to 3 people, sometimes 4, that have looked through it in detail and, with a varying degree of effort has issued that this work is not, obviously flawed in some way, right? And so then it has all sorts of implicit attributes, right, being published in journals. There's also the fact that, some journals will actually check if the work is reproducible, like the American Economic Review, extremely rigorous, like it'll take you a lifetime just to get a paper published with them. It's extremely hard and selective. So different journals do different things, and there's of course the one which is like, curation, right? How novel is the work? Well, if you see a paper that's been accepted in Nature, in the flagship journal, it's very likely like one attribute is like this work has been deemed really, really, really novel, meaning that it's going to be shaking the tree of knowledge, and people will be looking at it and thinking, oh, that's very new and very interesting, because it does call a lot of things into questions, or actually opens new unforeseen paths to new knowledge, right? So being published essentially is a set of attributes, right? And you could think of artifacts of knowledge having an inventory with sets of attributes, right? The question is like, can you unbundle them, right? Can you unbundle what it means to be published, rather than saying, hey, the journal should be doing all these, should be essentially bundling all these attributes together. Could you imagine, breaking this down and having, let's say, a phase that says, well, the basics have been checked, at least it's not plagiarized. That's an attribute, it's been peer reviewed, and here the peer reviewed, right? It's been peer reviewed in an adversarial fashion, right? This is the typical peer review is adversarial, right? Peer reviewers come in, they read a paper, they ask themselves the question, why should this not be published in this particular journal? And the third is, of course, the everything having to do with reproducibility that very, very few journals actually look at, and novelty evaluation, right? Meaning you're an editor, you're someone with deep experience about science in general. You spend your life reading papers, right? I mean, an editor's role, like a full-time editor, is someone who's incredibly deep and has a bird's eye view on an entire field, and is expected to make a judgment, make a call on what is important, what is deserving to be amplified in a community of interest, right? And that can go from a very niche community, let's say, fluid dynamics, a physics group, right, to like a very, very broad community, which is the entire community of scientists. That's a lot. So an editor has that role. And so you could think about having essentially badges that or attributes that are assigned at different timescales of an article. You could even imagine that being selected by a scientific community is an attribute, right? Maybe you have the fluid dynamics community, and they're there and they say, well, this work is remarkable, and we will add it as part of our curated collection, which will serve the function of, improving dissemination within our community. So it's essentially a loudspeaker. And that act of selecting that piece of work for curation is essentially represented as an attestation in the inventory of that research artifact. You can imagine things that happen much later in the life of a paper. For example, a wet lab experiment, maybe like a new antigene that is effective against certain tumor types, and it's completely new. Nobody thought about it. It's also high risk. We don't know if it replicates. We don't even know if we can reproduce the results. And it turns out we can, and it's been replicated by 2 independent groups, and the results are promising, and the effect size are meaningful. And this is a viable, like early drug target therapeutics. So that would be essentially an attestation that says that these results have been replicated, right, by 2 independent groups. And that could come, 5 to 10 years down the line, we don't know, at least 2 years down the line, given the time it usually takes to conduct a high quality replication of a piece of published research. So yeah, essentially think of every scientific artifact, every knowledge artifact as having an inventory where attestations, come in, come out, all along its lifespan, as a way to essentially reduce the incredibly dense information content of that artifact, but also to link it with object outside of that specific artifact, like a conducted replication.
And maybe I can I can add to that. I think that badges are actually very useful for authors and for the scientific community for two reasons, for two very practical reasons. One is it creates an additional way to give authors who go beyond the call of duty a way to actually get credit for that. Very often the hurdle there is to have a measurement system, a verified measurement system. So this is the ultimate power of why citation counts and publications and in major journals and impact factors and so on and so forth are so powerful and so influential, because they're quantifiable and they have been independently vouched, right? If we could have a way how we can evaluate research that goes beyond that and also gives people credit for literally going beyond the call of duty by sharing data, by sharing code, by engaging in, by producing reproducible work, by engaging in replication studies, all of these things, we need to create a measurement system that is independent, that is verifiable, and that gives a possibility to start steering the incentives of scientists into the direction that we think is valuable in terms of increasing the quality of science in the long term. And it's also a possibility for authors to increase their chances to get into these top journals. So the journal editors, they may not have the capacities themselves to evaluate all of these things in depth. But I'm absolutely convinced that the vast majority of them would consider it a positive quality signal of a submission if there is already a track record of other people having basically granted badges that are related to the quality of that work. So both of that would actually be really, really helpful, and it could help us also to get the adoption of such a system off the ground, because it is beneficial to the publishers and to the scientists and ultimately to science.
Fantastic. With that, I see we're about 1 minute away from hitting the top of the hour. So I think it's about time to end the community call. Might have time for one last question if anyone has anything pressing. Give it a couple seconds. And with that, I'd like to say thank you, everyone, for joining. This will be posted on YouTube as always, and look forward to any conversation in the Discord that comes around badges and the idea of scientific reputation, markers of quality for a paper, and everything else that was discussed. All right.
Thanks. Bye-bye.
See you, everyone.